And I'm really excited to actually introduce our speakers for tonight. So first, I'd like to introduce Nicole Mortillaro. She's an author, an award-winning science reporter with CBC News, and an amateur astronomer. Thank you so much for being here. Then we have Dr. Abrams. She's an assistant professor at the University of Toronto Institute for the History and Philosophy of Science and Technology. Her research examines how different forms of mathematical knowledge are created, why they matter, and who gets to participate. She's currently working on a book project about mathematics and masculinity in the early 20th century United States. Her interests also include global histories of data and data-based knowledges. And last but not least, we have Adaeze. She's a final year Ph.D. candidate in Astronomy and Astrophysics at the University of Toronto. Her Ph.D. research focuses on studying bright cosmic explosions such as fast radio bursts and luminous supernovae, using telescope data to uncover their origins and characteristics. Alongside her research, she is actively involved in outreach programs to make science more accessible to all and to inspire future generations of scientists across Africa and Canada. So welcome.
So this was such an inspiring movie. I mean, I haven't seen it in a while, and I just thought this was so many yes moments. And so I wanted to start off with what your takeaways were from this movie.
Thank you. Yes, I had not seen the movie in a while, and I forgot how hooked I get on these stories and the ups and downs. And I think for me, that's one of the great things that this movie does, is it draws you in. And I'm, as we've talked about a little bit, I work on these histories of sort of hidden labor in scientific communities more broadly. And I love that the book that this is based on and the movie just brought these stories to so many more people, which is great. And I also, a lot of those histories are often focused specifically on white women. And so I think that this movie does a really nice job looking at, right, we talk about intersectionality, not just to sort of celebrating these kinds of differences, but different forms of oppression. And I had appreciated going back through and seeing, these women are not only fighting husbands at home who want them to be at home.
I don't understand.
I don't want to talk about this again, okay?
A female engineer?
All of these things specific to being a woman in science, but then also fighting all of these, anti-black racism and the civil rights movement.
What would warrant a colored woman attending a white school?
I really appreciate this film doing that. Some of what I find a little bit frustrating, or maybe we should just stick to the positive for now and we can
No, go ahead.
I just, I think what's really interesting about this as well is this Hollywood telling of history, which again is great, right? It draws you into these stories. The focus on these three women is also great because you get to kind of see and celebrate the details. Just these undertones of sort of individualism and meritocracy are sometimes a little frustrating.
Catherine's the gal for that. She can handle any numbers you put in front of her.
Given the history of the broader civil rights movement, right? So we sort of see in the background these broader movements to sort of fighting for these rights in the United States.
Virginia acts like Brown versus Board of Education never happened.
And it sometimes feels like, okay, you have to be a genius black woman for us to care about your story in a way. So, right, it's like, oh, we hate that she's so good at this math and she has to run to the bathroom.
There are no colored bathrooms in this building or any building outside the West Campus.
That story's really compelling, but we also need to think about these broader movements, and just specifically in the context of the space race. There was quite a lot of pushback for the amount of money that was going into NASA at the time, and people saying, wait, we also are trying to fight for civil rights at this moment, and should our attention be So just to kind of, as I was watching this, remembering that we see the kind of background of what is one of the most important collective movements in the history of the United States being told through these very individual stories. So just that tension I was reminded of, but thanks.
It's interesting because, do you know that song, Whitey on the Moon? Exactly. So I don't know if you guys have heard this song, Whitey on the Moon, and it was really talking about exactly what you're talking about the space race. in a time where we're looking for civil rights, equality, etc. So that's why I thought that's a really good point.
I mean, you can't do everything in a movie. I get that, and choices are made and such. But I do think that that is an important part of this. I mean, even when they're showing footage in Cape Canaveral in Florida.
It's a historic day here at Cape Canaveral, and here's what we can expect. Alan Shepard and Freedom 7 will be launched into space at an altitude of about 116 miles an hour.
There were major protests by Black people across the country were busing to those launch sites to say, hey, okay, this is a lot of what's going on. Let's talk about, and like it's really hard to wrap your head around the huge amounts of money that the U.S. has put, like totally unprecedented. The U.S. had not spent this amount of money on anything ever because they effectively lost the race.
The Vostok 1 rocket delivered Russian cosmonaut Yuri Gagarin's 3KA capsule into orbit at 6:07 UTC.
Beat the pants off us. Let's go.
This is a day of unprecedented triumph for the Russian space program and a crushing blow for America in the race for space.
Right? All of that stuff about the Russians, everyone, they lost. And so much money went in, and people were really saying there were also huge amounts of poverty. So those footages don't show the kind of protests of the space race itself. There's a little bit of this boosterous, like, woo, we're gonna do it.
Rah.
Which I get on board with too, but just, other reminders.
Adaeze, how about you? How did you feel about this movie? Because you hadn't seen it until recently, right?
Yes, so, and funny enough, it still looked like this is my first time. I don't know, it just had a way of captivating you and you just feel immersed inside that. I totally enjoyed it. And I think it's so inspiring because for me, I could see myself. Yes, so I could identify with some of the challenges, even till now. But I rather consider it as an expository into even deeper issues that happened in the past. I'm grateful that I wasn't in that past, but yes, I think
yes.
Yes, but I could learn from some of the things they did. For example, the community they had to build to strengthen one another despite the limitations surrounding them. I think that really helped. This is my own lesson, especially because I identify with them, right? So I could pick, okay, the importance of community, the importance of even wanting to be better. So despite they are being undermined, but they did not stop. So they keep pushing. They continue to, go for what they want. Individually, we could see how, the engineer wanted to be an engineer. She had to go all out. Oh my goodness! I couldn't imagine you have to get a court ruling to go to school.
What would warrant a colored woman attending a white school?
But that's tenacity right there. That's going the extra mile. I'm not gonna say that it's easy. Like I've seen myself do that even now. It takes a lot of courage. It takes a lot of self-motivation, and even when everyone else think it's impossible, including the spouse, which is so, I don't know where she got that energy from, but I
know.
I think that is inspiring, and yes, I can tell you that it always makes you stand out, such that despite those limitations, because of your competence, you cannot just be denied, right? Like people can't keep pretending that you are not there. But I must say that's like doubling up on your effort compared to what average you could have done. So which is stressful, but I also picked that up.
Right. I mean, like you said, it's. I mean, the tenacity that Mary Jackson had was incredible, but and it didn't matter that for all those women how competent they were. It just didn't matter. They were women, and they were Black. So I want to touch on both of you. I mean, we had this great intro, but I wanted to touch Adaeze. Can you talk about what you're doing right now, what you're studying? I think people will be really interested in this.
Yes, so as a Ph.D. student in astronomy and astrophysics at the University of Toronto, I work on understanding very peculiar transients. So transients are quite bright explosions in the universe. They come from distant universe. We know this because we can tell they are not from the Milky Way. So I work on two of them, fast radio bursts, which is one of the most recent discoveries, and then very luminous supernova. Those ones have been known for a while to be, as a result of the death of a massive star. Towards the end of their life, they blow up in an explosion. However, we do not even understand whether it's a star or a binary system that actually blew up. We just noticed that explosion. So part of my work is to discover what the progenitor is. And also for fast radio bursts, like every other scientist, we're trying to understand where it's coming from. We do not even know the galaxies. Some of them we don't know the galaxies. And we want to know what object is producing those emissions. So my work is to use different telescope data to try and figure this out. So I combine those data using some sophisticated technology and statistics to make sense of where these emissions are coming from.
Yeah, and these fast radio bursts are fast. They're like milliseconds, right? Of its explosion of energy. And they were only discovered, 2007. Yeah. Like, which is wild when you think, astronomy, we think we kind of understand everything that's, not understand, but we know what's out there, but here's this new science. This is amazing.
Yes. So fast radio bursts, which is one of the newest, we just started seeing or detecting more of it ever since the discovery in 2007, but that doesn't mean that's the originate time. We don't know. It probably has been there. We're not finding them because we have limitations with our technology, and we can only do what we know. So now we know we could prime our telescopes to be able to detect them, and we have found more of them with the CHIME telescope, which is the Canadian hydrogen experiment in BC. We are finding over 1,000 per year now, which is incredible. Yeah,
it is crazy, and the fact that they were discovered by accident, and then now we're finding, there are also ones that repeat.
Absolutely,
it's just crazy.
Yeah, we still wondering whether those ones that repeat are probably coming from a particular source, which is possible. It could be that there is a central engine giving off that emission, right? Which is why we could get them multiple times. But there are also some that are just one-off. We don't know whether it's probably a catastrophic one. So we are trying to understand that through the different analyses and experiments that we are doing.
Yeah, and Canada's a leader in it, which is fantastic.
Yes, Canada is leading that.
Why don't you tell us about your work and what you touched on it a bit? What your specialty is, and tell me, also, have you had any challenges?
Sure. I will say I was an engineer. My first degree was in engineering, and I think that. Looking back, I now understand a lot of those dynamics more than I did when I was kind of in it. I was a mechanical engineer, and there were like 5 women in 100. So I just have learned a lot more about these kinds of dynamics in the histories. Right, so I'm a historian of mathematics, modern mathematics, and part of what's interesting to me here is this longer histories of these teams of computers that, often in large astronomical projects, pre-Enlightenment, they have all of these teams of people working on these calculations, and a sort of turn of the 19th century with taking some inspiration from kind of Adam Smith division of labor, these new understandings of economy, there sort of starts to be a breaking down of those teams in these hierarchical kind of assembly lines, so that you end up with some of the hierarchies we see here, where it's the mathematicians at the top who are, doing, in cases of certain calculation projects, kind of figuring out what's going on, and then it's kind of being translated, sometimes referred to as like middle management, and then there's laborers at the bottom who are doing these kind of calculations and recording them. And so, part of what I'm interested in, these shifts in sort of understanding of that labor as something that can be mechanized. So that's when we start to see things like Charles Babbage and creating these machines, eventually IBM-like machines that can do this. But then also that, calculation was once something that mathematicians like Euler and Gauss would do to show their intelligence and their brilliance, but sort of started to become something that was just, routine labor, and so not something tied to intelligence, and therefore something that women could do. Specifically educated white women for a long time who would be underpaid, but then were thought to be they weren't imaginative, and so they were reliable calculators, whereas kind of before they were thought to be too imaginative to be reliable. So there's these shifts in how kind of cultures have understood women and mathematics and calculation that we can see a lot in this film. I was really interested in, I realized that I wasn't sure about the career trajectory of Catherine.
Catherine is the gal for that.
I kept wondering, can't they just promote her to mathematician? Was she a calculator for the rest of her life? Yes, they named a whole building after her, but she was doing work that wouldn't have been thought of as calculator or computer at a certain point. And so I was just curious about kind of where that fit in. And yeah, I think, like you were saying, the community element is something I'm really interested in, and I think that one of my favorite parts of the movie is when Dorothy's like,
I'm not accepting reassignment unless I bring my ladies with me. We're gonna need a lot of manpower to program that beast. I can't do it alone. My gals are ready. They can do the work.
Adaeze, how about you? What challenges have you found? I mean, your background, you're from Nigeria.
Yes.
And it's not a lot of astronomers there or interest. Did you find any challenges when you started?
Yes, so I will take it back to when I started applying for graduate school. By the way, I got to know about astronomy through a program that I was opportune to be in attendance, and then I met some international instructors, some astronomers. And that was the first time I even got exposed to the reality of doing the research. So I've heard about astronomy a little bit in my final year of undergraduate, but I didn't know I could make a career out of it. I didn't understand what doing a research in astronomy would look like. So, but ever since I was in this program. By the way, I'm an instructor in that program right now. So I began to think about a career, and then I was led to the different method, how I could get into grad school, the application processes, and all the, is a hurdle. Anyway, so I began to try, but I got a lot of rejections. Oh my goodness. I ended up doing my master's back home because I did not get admission. But even while still doing my master's, something in me, because I already know that, okay, we are still coming up in this program, so let me tell myself the truth. I need to get an international education if I want to thrive in this career. So despite, started doing my master's program, I continued to apply. I even applied to U of T and got denied. Anyway, but I did again. The last time I applied, I did 7 applications to different schools. University of Toronto was the last one because I gave up. But someone encouraged me, you know what, just try again. It doesn't cost a thing. Well, one of the things the rejection did for me was to second guess myself. There are so many options. Of course, it was clear that coming from my background, I wouldn't judge the committee to think that I'm not qualified. And then, I'm also a woman. There are other factors also included, but I just couldn't pinpoint it at the time. I just felt bad. I was not encouraged to continue, and then I wasn't even sure I would get a chance. I was just doing it to justify myself, my conscience. So gratefully, I got in, and then it's been a journey since then. First, there was the culture shock. There was different educational system I had to adapt to, so many things to learn, And I must say it's tougher for me because of where I'm coming from. So it's a different system. So it's quite a steep learning curve trying to catch up. But more so, coming from a woman's standpoint, a black person, I remember one of my lecturers saying to me, "Oh, you do like to do things your way." Because during we were taking this course and there were homeworks, and I always do it where I understand, but that's not quite how most people are doing it, I guess. But I like the fact that the professor was able to see it the way I'm saying it, instead of just judging me right away and maybe ruling me out. But when I explained, she was like, "Okay, I see," and I hope that helped me scale through that course. Some other person could just rule me out right off because I was thinking differently. I probably had a different trajectory when it comes to taking problems or even solving problems. So I had to go through that. I would say that I did most of the learning because I had to adjust to the system, right? Which is tough. I wish maybe some people could adjust for me a little bit, but that's not going to happen. You are the one in a new system, so you have to adjust. So I must say that it's a lot better compared to the movie, right? Yes, and my department, they did try their best to have an inclusive environment. I must say that most of the challenges I had were even within my peers, like students, they don't know so much as to what to do. Some people are even scared. They don't know what to say to her that could be offensive. Like, people are just, that's how I interpreted it anyways. Not like they told me, but I could see that people are tensed and they don't just know what to do. So everybody, were minding their business. I had to also learn that because from where I come from, we live in a community, and more mingling into everybody's life. So I have to learn to give people their space. I must say that I do have a few allies that helped me. So from time to time, they encourage me, even though they are not blacks. They continue to just give me the confidence to know that even them, they are struggling. Sometimes they just give you that reassurance that you are not alone, So, and those were helpful. And I had to join a group away from school just so that I could feel like myself, because truly I wasn't feeling myself. I had to join a group where I see more of black people and just that community, and I must say they were supportive up till now. They've been supportive. So that's why I said I see myself a lot in that movie. When it comes to doubling up on my efforts, that is me. Yes. So
well, it sounds like it.
Yes. Typical work that could take 1 hour to do, I might take more than that, just so that I can give my best. There was already a difference with even comprehension or doing normal things, but then even so that I can be confident with what I've done, so there is that extra mile all the time, almost for everything. And I don't know, maybe it has helped. It's not such a bad thing, but it's also not so good because it's a lot of pressure. So this is not like an advice. But I also see that in that movie. That's why I'm pointing it out. Like, people going the extra mile all the time.
Well, that's a lot that you find with women and women of color, that we have to push harder to get to where we're going. Ellen, I wanted to talk about math. I'm not good at math at all, but you know the history. So with women, you mentioned earlier the white women computers, which I think of the Harvard computers, but as much as we've come a ways, we've started, women, okay, white women computers, and black women computers, and then, but today, society think that girls don't like math. So can you talk about that? Have we come that far, really?
Yes, and this is such a great kind of example of the fact that, okay, there aren't necessarily segregated restrooms. People aren't running through the rain to go to the bathroom, hopefully. In theory, these educational institutions are open to women and people of color. However, this does not change the fact that, as you're seeing, these are still certain scientific communities, and certain communities, knowledge communities, are created by and for certain people who are then assumed to be more belong in that space or do things a certain way, right? It's a great example of the fact that, like, you know, we think of math as this abstract thing that is done one way and there's a right or wrong. Whoever told you you're bad at math is wrong. Like, there are very narrow conceptions of what we think of. I like to include astronomy within mathematics in a lot of ways.
For sure.
But yeah, so this is an example of I think your story is especially interesting because it has to do with this sort of international, where do you have access in which places to these kinds of communities that then there are gatekeepers, right? That say, okay, you can come, you can't come, and even when you do come, it's just gonna be like this entirely other community that you have to adjust to, right? And so it's these things that might seem small but end up being, they build, right? And they sort of perpetuate. And so part of what I'm interested in is I study masculinity in mathematics. So why is it that so mathematics is really interesting sort of historically, because in some cases, sciences like physics or chemistry or things like that, women were officially not allowed in a laboratory setting, right? It was too dangerous. There are these assumptions that men were being really brave when they were doing these experiments. Or in engineering labs, right? As we saw in the case of Mary.
One tunnel test.
Our shoes worth your life.
Women wouldn't be allowed in the shop, right? Like, this is a physically dangerous place, and why would we allow women in there? And so mathematics in some cases was a way in for women that was, you know, okay, we don't need to be in a lab or we don't need access to the shop, but, you know, like these women, we can do the math, so watch us do the math. But it also is sometimes really problematically, I think, held up as this sort of beacon of objectivity or other kind of form of knowledge that is only accessible to certain people and not others. And I think that has been propagated in different ways in different times, but continues to be very problematic, even when there are, you know, important women mathematicians who do a lot of really good work trying to, you know, programs to get young girls involved in mathematics or computer science or things like that. There is still, everyone's working against these kind of cultural assumptions that are, yeah, still a big issue.
For me, who told me I was bad at math was my grade 2 teacher. And she said, you'll never be good at math. And I swear, I think that, like, put that in my, you know, like, it's so, but why do you think math is still regarded as that scary subject, you know, when you go to school?
So I wish I had an answer to, like, this is how math should be taught in second grade that would kind of solve all of it. But there are ways that other communities or cultures or kind of, you know, other pedagogical methods that hold math up not as like the point is to get to some sort of answer of some calculation, which if you talk to a mathematician, their lives are not at all just like an accelerated version of what you did in second grade, right? They're not necessarily sitting there and being like, okay, I did my homework, like, let's hand it in. But there's more of an emphasis on group work, like we're gonna work together and kind of figure out, you know, what's going on in this, what can we think about in that way, what have we learned from this, and not just like, okay, here's the answer, did you get it right or wrong? Again, there are people who can speak more specifically to math pedagogy and sort of why it's a problem and how it works. I think there is something to be said for, I don't know, math education is such a huge thing that a lot of, so I mean, I think it's worth considering what we're doing to children in second grade that's making them think that math is so hard, and not necessarily, end of the day, right, mathematics, like other sciences, is something that humans do and create. It can be very creative, it can be, you know, I'm terrible at art, but like, nobody kind of equates that as sort of these other ways of thinking and these other ways of producing things in communities. And so I think, yeah, I mean, it's a long answer, but there are different ways that mathematics kind of gets that reputation, also including things like, why are standardized tests, why does math tie in for intelligence in different ways? Like in some cases, it's so random to be like, oh, good at math, you should go to college. And it's like, okay, really? You know, like where does this come from? And there are these really long histories of different conceptions of what mathematics is, why it matters, who should get to do it, that all kind of tie in.
What got you interested in it, in this study?
It's a great question.
Sorry.
Yes, no, it's good. So I mentioned I was an engineering undergrad and just didn't know that you could do histories of science in this way. And so when I started kind of learning more about histories of science and went to graduate school in the history of science, I loved that math was sort of held up as this extra hard case, you know, like, does math have a history in the way that some people like don't think of? And so I liked that. And then, yeah, I think I kind of got sucked into all of these questions of the power of math and the image of math. Not just to mention some very fun stories within the history of math that I think are interesting.
I was saying earlier, math kind of fascinates me, even though I'm not good at it, because. But I've been teaching myself along the way. But what's interesting is I'm saying it's a language. It fascinates me. Like even just equations being a language. And seeing this board of the chalkboard, I'm like, I don't get it. What are they seeing? I just see a bunch of squiggles. But it's amazing. Now, Adaeze, I wanted to ask you because I was telling you a story earlier that I love astronomy. I'm an amateur astronomer. I love it, and I've always loved it. And when I went, I wanted to become an astronomer, but because I wasn't good at math, math wasn't my strong suit. How's that? But I was told, oh no, you need to be perfect at math to be an astronomer. And I just say, what do you say to that? Because you have a different feeling.
Yeah, so I was also going to add to what she said in terms of how can we do better so that mathematics is not perceived like abstract. And I think it's not just mathematics. Most of the science core subjects like physics, chemistry, I know this because I also perceived physics as an abstract subject. Yes, I don't know how I managed to make it in. Anyway, yes, I had that issue, and which is one of the reasons why I am also passionate about making science accessible. That's one of the reasons why I'm into science communication, so that people coming after us do not have to go through what we went through. Like, no one should discourage you, if you wanted to do astronomy. So, to answer your question, I don't think you need to be perfect in mathematics to do any of the science courses, to be honest. And I think one of the things we could do would be to humanize these subjects. I think it will help for people to identify with them, and that will encourage assimilation, even like understanding the concept, whatever equation or the method, like making that human connection to it. I think it would help. So I think it's in the teaching method. It lies in the teaching method. I find this helpful even for physics. So I coach teachers back home, especially on how to teach, so science teachers, and I find that the way you pass down the knowledge is way more important than the knowledge itself.
No, that's an excellent point.
Yeah, so I was a victim, which is why I thought that this could also hinder so many people. So we should get things better. And for myself, I learn better when you give me analogy, you give me illustrations, right? It makes sense. So why not? So I think the bottom line is that anyone can make it. Yes, you don't need to be a maths guru. I'm not. I don't think I can get into mathematics level like you.
I don't think of myself as a good mathematician.
I don't, right?
Okay, like
and
people
in these days of computer programming, most of what we need to do real science is computers. You just need to program it, and it does the work for you. So you don't have to do all of those kind of traditional mathematics that you think about. No, that's not what we are doing.
I mean, I think, so the idea that mathematics would be sort of this requisite, I mean, again, if we think about scientific knowledge as kind of a way of understanding the world, mathematics became really important to that project during the Enlightenment, right? We started to think of kind of mechanical understandings of the world, these really powerful ways of understanding what people were already trying to understand, but through mathematics. And so just to say that, you know, there are strange ways in which mathematics becomes like a, you must do this or you must do that. But I think what's really fun, the scene where Catherine, let's see, that, you know, they're saying, okay, we have to build this mathematics to figure out what to do with the parabolic formula when it's coming down.
The problem is when the capsule moves from an elliptical orbit to a parabolic orbit. There's no mathematical formula for that. Because we can calculate launch and landing, but without this conversion, the capsule stays in orbit. We can't bring it back home.
Maybe we've been thinking about this all wrong.
How's that?
Maybe it's not new math at all.
It could be old math. Something that looks at the problem numerically and not theoretically. Math is always dependable.
For you, it is.
I think it's hilarious because Euler, you know, he's like,
Euler's method.
Euler's method.
Yes.
That's ancient.
It's not ancient, right? It's still technically modern, but old for
How
sure.
old is it?
Yeah, I mean, Euler's 1800.
I know it's quite
Leonard.
old.
Yeah, it's quite old. But you
It's
know,
not ancient.
I don't know. It's just that always cracked me up because I don't know anything about ancient mathematics. And so it's like, but I really like that scene too because just looking at the mathematics then was a re-understanding of the problem. You know, like they're kind of using the mathematics in that scene to understand, to kind of reformulate the question and re-understand it. And so I think that's cool. But again, maybe not necessary for everyone who's in the room to go at it that way. It'd be great if you had people going at it another way as well, kind of at the same time.
But then she made a point that needed to be solved numerically. The computer comes in.
Put it in the machine.
Yeah, so I think these whole sciences are intertwined at the end. And in the modern world, you don't have to get into all of those 20 pages trying to prove equations. I don't think they do that anymore, even in mathematics.
Yeah.
So, because now you have computers, so you just need to get the basics, through mathematics, get to the theories, I'm hoping, and then there is a point where the computer could take it from there. I'm hoping.
Okay, but John Glenn didn't want to go to space unless he could look someone in the eye.
Yeah.
Let's get the girl to check the numbers.
Just there are still mathematicians. I think the role of computing within mathematics is people feel very differently. Some mathematicians feel great working with computers. Some are happy to throw it off. A lot just, you know, are still not necessarily working. So yes, all of it together. But I did like when John Glenn just wanted to hear what Catherine came up with.
Get the girl. Adaeze, can you talk about science communication, SciComm? Why do you feel passionate about that? And do you find there are challenges that to that?
Yeah, so I think the main reason why I think science communication is important is because why do we spend all of this money doing all these sciences and people don't even know about it? People don't understand it, at least to make sense to them. So we can publish papers, write technical papers, and we've not made any impact. So that's my main goal, right? The fact that we put in all this work, people should know about it. Then there is also the issue of demystifying science, just like what we've been talking about, right? So if we are going to get more people involved in STEM and keeping them inspired also, then we should teach it properly. And one of the ways will be making sure that we are communicating it in a way that is accessible. So that's what science communication is about, making it accessible to anyone, whether a young child or someone who is not learned, whoever, right? So that's my two main reason why I really think science communication is so important.
Well, that's my job, so too. And but it's interesting because in my years of reporting on science, I have come across a lot of people in academia who say that has been the biggest, you summed it up perfectly, that it's the biggest challenge to get, yeah, you wrote this paper, but how do you get it out there and how do you get people to understand it? And so I know that universities are trying to make, science communication like a course that people need to take. But do you think, this to both of you, do you think that we need to kind of inspire younger when it comes to math and like any science, math and science in general?
Yes, I think we need to inspire the younger generation. And one of the challenges I already see is that we have different kinds of sciences, and becoming a science communicator, you can only do so well in the area where you are specializing. So I also see that being a challenge. So, but we could normalize that, right? I don't see a lot of it, to be honest. I know you said universities are making effort, but I don't see it.
Really?
So maybe it's still on the pipeline. I don't know.
Yeah, that's true. Yeah, it has been a recent thing.
Yeah, so because I don't think those opportunities are available, and it's not even acknowledged as one of the routes, career routes, for example, which is maybe where they should start from. And then maybe empowering students to get trained or whatever, to be able to take on that career. So I think that a lot of young people could think science is just a waste of their time if we do not communicate to them, which is why I think they should be inspired. Yes.
Yeah, I mean, I loved what you said earlier, too, about it's not just inspiring students, but like staying inspired as a working scientist. I think it's really interesting. So I love the idea that like science communication might inspire all the generations, and maybe rethinking science will hopefully make it so that children in school now are not having bad experiences, quote unquote, but also maybe undoing some of the bad experiences that people had. And I mean, I think it's really interesting, again, in the context of this film, there was so much focus after this point, again, when the US sort of lost, or everyone was so worried about the space race and the technology, and that everyone is so freaked out about science education in the US, the amount of funding that went into jobs for physicists. You could basically, if you could do physics, you're gonna get a job, you're gonna make money, you're gonna buy a house in the suburbs, you're gonna have a car. There was just this clear idea of people thought that we could solve everything. Again, sorry, I'm from the US. I get, not we, but we just needed our students to not be so terrible at math and science, and that would solve everything. And I think it's tricky because there's just such clear thinking in that, right? Like the atomic weaponry, computing, there were these clear like, oh, this is the future, right? And they kept being like, this is the future, and it's hard. It's a little concerning if anyone's ever like, this is the future, and so let's educate everyone in that way. I think it's a little tricky, but yeah, I mean, I think they're important questions to ask.
I think balance is the key. Like, no discipline is more important than the other, but like just communicating them properly. Because I understand what you're saying. Like, it's similar also in Africa. Like, we think science is more superior than maybe arts or social sciences, and that gives this wrong vibe. And so that's not what we are talking about. So yeah, so we need that balance.
But you're right. Like, his math is for smart people. Art, like it is kind of like they're not treated equally at all. Can you explain the critical suggestion about using Euler's method?
They were thinking, in order to do this, we need to do an analytical solution. We need to be able to write down analytically how we change from the elliptical orbit to the parabolic orbit, and then solve that particular formula that was an equation that's written down. And the idea, instead, to use Euler's method is to do a numerical solution to the situation that you set up. So you don't need to be getting an exact solution. A numerical solution will be good enough, provided, of course, that you keep testing what the accuracy of your solution is. So when she, in the end, concludes that you'll be there accurate to within 20 miles or whatever the number was, that was her estimate of the error that's going to come from Euler's method. So it was the idea that we can use a classical method, about maybe 200 years old, to instead of having to come up with something entirely new to solve the equation.
Thank you, that's so helpful. And just to say that, like, that's a pretty common, at least historically, again, not a mathematician, but within things like ballistics trajectories and some of the other things that have these big computing projects, if you don't necessarily know the exact formula or all of the things affecting a trajectory like of a bullet or an orbiting thing, you can just try to get some numbers out numerically that will have a certain amount of error, but will hopefully tell you enough to get him in the ocean in the right spot.
Yeah. I mean, it's so challenging. You know, it seems like simple, but like I was saying earlier, Earth is moving and is rotating and all this stuff. And I mean, I find it fascinating that, you know, math can do this. How accurate is the math in the movie? Are the big research posed actually the challenges that they had to solve? I can say about the challenges they had to solve, yes, absolutely, because I love space in it. But yeah, the math accuracy, take it away.
Well, I think the things that they were writing on the blackboard weren't really exactly the kinds of questions that they were addressing. But what was really nice to, I think the one point, as we were saying at the beginning, which I think really failed to communicate part of what the mathematics is about, was the moment when Catherine got up and said,
The goal point for re-entry is 2,990 miles from where we want Colonel Glenn to land.
That's not actually the right question to be asking. It's not, if we start here, will we end up in the right place? That's what you do to check your answer. But the real question was, if we want to end up there, where should we start? And so that's the backwards question, the inverse question. And it's always the inverse question which is harder, but that's the challenging question that you're trying to answer. And so it would have been nice if they could have communicated in the movie that that was the hard thing. And so then the forward question was the calculation that she then showed, just check that she got the answer right. So that to me as a mathematician, that was a little bit disappointing that they didn't address that. Other parts of what they were doing, showing the fact that we need just trigonometric functions and using those, and that was spot on. Or we saw the logarithmic function showing up at some point, that was totally on. So and indeed the way that there were a lot of detailed, just numerical calculations that you have to do when you're calculating with these functions for which you don't necessarily have explicit formulas, and understanding what kind of error bounds that you need. I mean, all these things weren't exactly addressed, but they were kind of peripherally there, and you could get a little bit of a sense of it. Sorry, I shouldn't be taking over here.
Hey, you're answering the questions. That's great. Okay, what do you think is the coolest math calculation used by NASA in the past or currently? Okay, on a personal level, for me, I think it's sending spacecraft so far away, I mean to Pluto, like when we had New Horizons, the fact that you're having to calculate not where the planet is, where it's going to be in the future, and I think that's amazing. But anybody else? Weigh in? No?
I mean, if I can interpret the question differently and just sort of tie into what you were saying, I'm always interested, again, I'm not a filmmaker or an artist, but what they do decide to put on the chalkboards and kind of what is up there. I'm sure, hopefully there's some thought behind it, right? Like hopefully they've been like, okay, this looks good and this looks smart and this is a little bit what would have been up there. But there are, scholars have written about just the kind of symbolic value of chalkboards and chalk to the discipline of math. And so all those scenes where they're handing her the chalk, there's so much written about kind of what that means culturally. So I guess a funny interpretation is I liked all those parts.
Look. The feels
exactly.
That's why I noticed earlier.
That's a really good point.
I won't have an answer to that question, but we are very into chalk. And so but certainly, who controls the chalk? Who can actually control what's being communicated? And indeed, actually, the way that we saw Catherine constantly typing, she was doing the typing, of course, and I'm sure the band didn't know how to type. And that also she was, she insisted on putting her name on it over and over and over again.
I have told you this. Computers don't author reports. Fix it.
And that's very much who controls the pen.
There's also a specific term for scientists who don't get credited. It was officially called the Matthew effect, where if you work for a famous scientist and you do a lot of the work, but it goes under their name. And historian Margaret Rossiter wrote about the Matilda effect and how this happens specifically for women whose names don't end up on the paper. Anyway.
Interesting.
Throws the chalk.
Yeah. All right, and the final question we have, this is for you. Any comparisons about how math is perceived or taught in Nigeria compared possibly to here, to Canada?
First of all, I've not been in a mathematical class before in Canada.
Yes, okay.
So I can't give a direct comparison, but I could give for physics, if you don't mind.
Yeah, I mean.
Okay. Yes, comparing physics, especially at the university level, I would say that there are more effort to break it down and make it more relatable over here compared to in Nigeria. And that was one of my biggest challenge, because I was scared of physics, even though I did it.
Really?
Yes, I managed to scale through. I had to study on my own, do whatever I have to do. But I didn't understand a lot of the things I was reading. So, again, why I'm passionate about making science accessible. But over here, I find that in undergraduate level, there are more teaching methods applied, different techniques, just to make sure that the students get it. So, yes, very different. Very different.
It's interesting. You're sounding like Mary Jackson. You're pushing through here. It was hard. And it sounds like you too are very, very focused and driven. It's amazing.
Excited for the movie someday.
Well, thank you so much. You guys are wonderful, and thank you for speaking with us tonight.
Thank you for staying.